Assalamu alaikum wa rahmatullahi ta'ala wa barakatuh. Today, inshallah, we will continue discussing with you, explaining for you the normal distribution. Today, we will take the standard normal distribution. طيب. Let's review what we took in the last video, last lecture. Here, the normal distribution, we said that there are many cases where the data tends to be around central value. This is the central value with no bias left or right, and it gets close to the normal distribution. You see, this is the situation of the normal distribution. Okay, here all the data almost are around the central value. This is the central value here. Okay, this is the normal distribution. Okay, so any statistical experiment, okay, if we have continuous random variable like height, length, like mass, like time, or any other things, okay, which can be expressed using the real numbers, or which can be expressed within interval, okay, not as individual value, okay. So if we have statistical experiment deals with that continuous random variable, and if we classify this continuous random variable into intervals, and we count the number of favorable outcomes here, and we constructed really bar chart or histogram in that way, and we found that the shape of the histogram in that form, this means that the data tends to be around central value. This is the central value, which is the mean. Okay, next. So the normal distribution is called bill curve. Bill curve. It is like the bill, exactly. And here, many things closely follow a normal distribution. Yani, what type of continuous random variable which will follow normal distribution? Heights of people, size of things produced by machines, errors in measurements, blood pressure, marks on a test. Almost this continuous random variables, these are continuous random variables, okay? If we construct histogram for that continuous random variable within, let's say, a certain group of people, we will find that it is normal. It means the data is around a central value, which is the mean. Okay. Next here. So in this case, if we have continuous random variables which follows the normal distribution, okay, always the mean and median and mode are equal. In that case, if we calculate the mean or the mode or the mean, median or mode or mean, all of them are equal in the normal distribution. Normally distributed continuous random variable. Okay, we will find that in this normal distribution curve, bill curve we say, it is symmetrical around the mean. Symmetrical. Once we say symmetrical, we will say it means there is a kind of, let's say this symmetry line will be like a mirror line. The reflection in that line, so symmetrical. So if you have a value here, the corresponding is here, the same distance. Okay, symmetrical. طيب. So always the normal distribution curve is symmetrical around the mean. Around the mean. The symmetry line, it is on the mean or median or mode here. And divide definitely the area of under the curve into two equal parts. Two equal parts. Okay. Here, the curve, we will continue to speak about the characteristics of that curve. First of all, we will find that this curve is asymptotic. Asymptotics. What does it mean, asymptotics? It goes from here to both sides, then closer to x-axis. Closer to x-axis. This is called asymptotics. Moves to both sides to go then closer to x-axis. In other words, this normal curve has two tails. One tail toward the positive x-axis and the other tail toward the negative x-axis. This is the meaning of asymptotic to the x-axis. Always, ya shabab, the total area under this curve, okay, is 1. This value 1 reminds you with what? Yes, exactly. It reminds you with the total probability of a certain continuous random variable in a certain statistical experiment. Okay, the total probability of all events always is 1. And here the same thing. The total area under this curve is 1. This is one of the most important really characteristics of normal distribution. We are reviewing. So far, I didn't come to attack the standard normal distribution. We are speaking about normal distribution. Okay? طيب. Here we have another, as a matter of fact, another property. This is for your knowledge. We say that in the normal distribution curve, if a certain continuous random variable is normally distributed, it means the data is around central value, which is mean. This is the mean here. This is the value of the mean. In the x-axis, this is the mean. Maybe it is 15, 20, 25, according to the scale of the value. So this is the mean here. We call the mean mu. Mu. Empirically, we found that there is very significant and important property of normal distribution. This is for your own knowledge. That always, look here, this is mu plus sigma, mu minus sigma, and here, mu plus sigma. In the red area, do you see that red area? So always, if we have a statistical experiment, and you calculate the mean, x bar, if you remember, and you calculate the variance, then the standard deviation. Sigma is the standard deviation, okay? Standard deviation. So we found, مثلا, suppose that the mean was 10 and sigma is 2. Okay? So here it will be 10, let's say this is 10, and here 10 minus 2, which is 8, and here 12. Okay? We found empirically that almost any continuous random variable which is normally distributed, we find that the area under the curve, madam, since it is normally distributed, then we can draw the normal distribution to express that random experiment. Okay? We found that the area under the curve between 8 and 12, always, not 8 and 12, we say mu minus sigma and mu plus sigma, always 68, almost 68%. Okay? 68%. In any continuous random variable, okay, this is a major and very important property in the normal distribution. Always mu minus sigma to mu plus sigma, all of that area, the red area, is 68% in any experiment which is normally distributed. Okay? طيب. And here, look. Here this is mu plus 2 sigma, and I'm sorry, 2 minus, and here minus, here mu minus 2 sigma, and here mu plus 2 sigma. So the area from here till here, all of that, do you see? All of that, from here to here, all of that. So any continuous random variable which is normally distributed, we find that the area under the curve is 95%. In other words, 95% of the data of that experiment are located here. Located here. Okay? The height, suppose that the mean height of the students in your class, suppose 165. Okay? Suppose 165. And we calculated the standard deviation in your class, S or sigma. Okay? We find that in your class here, this is the height, 165, and we find that the sigma, standard deviation, is nothing but 5. So here, mu minus sigma, it means 165 minus 5, it is 160. And here, 165 plus 5, 170. What does it mean? It means 68% of the students in your class, their height are from 160 to 170, almost. Okay? And the same thing here. Mu minus 2 sigma, what does it mean? Mu 165. 2 sigma is 10. So mu minus 2 sigma, it means 165 minus 10, which is 155. And here, mu plus 2 sigma, it means 175. So we will find that 95% of the students in your class, their height from 155 to 175. Is that clear? Then what else here? Here, mu minus 3 sigma. And here, mu plus 3 sigma. Okay? Mu minus 3 sigma and mu plus 3 sigma. What does it mean here? Mu, 165 minus 3 sigma, yani minus 15. It means 150. And here, 180. What does it mean? It means 99.7 of the data are located, 99.7 of the students in your class, their height from 150 to 180. So in general, we will say that any continuous random variable which is normally distributed, always, as we said, or almost, we have 68% of the data between mu minus sigma and mu plus sigma. This is mu. And we have 95% from mu minus 2 sigma to mu plus 2 sigma. And 99.7, yani almost all the data from mu plus 3 sigma, mu minus 3 sigma to mu plus 3 sigma. After that, yani almost, yani very rare case, okay? So 99.7% of the data, it means even 99.7 of the area of that normal distributed located between these two values. This is a very important and significant property of the normal distribution. طيب, now let's come to the standard normal distribution. We studied together even, I told you if you still remember, if we have a continuous random variable which is normally distributed, we say that the normal distribution has two parameters. It is mu and variance. Mu and variance. طبعا, since we have many statistical experiments and many normal distributions with different values of mu and variance, if we want really to convert all of these different normal distribution of different values of mu and the variance, we will convert it to the something called the standard normal distribution. Like what? If you have different currencies and you want to change them in terms of Turkish lira. Okay? This is the issue. How to convert different currencies into one currency, which is, let's say, Turkish lira. In order to know and deal with these currencies, okay, I have to understand these currency in terms of one currency. I will call the Turkish lira here is the standard currency. The same thing here. We have different normal distribution with different means and variance. We want to change them into the standard normal distribution. We call it Z distribution. Z distributions. Once we say Z distribution, it means it is the standard. While with the normal distribution, we are dealing with the letter X. But since we are dealing with Z, it means it is standard normal distribution. The significance of standard normal distribution, it will help us to calculate the probabilities, okay, in the questions. And this is our main target. As a matter of fact, to calculate the probability for the events when we deal with the continuous random variable. Standardizing the different normal distribution into the standard one, to standardize the different normal distribution, this is another topic. Inshallah, I will give you another lesson for it. But now we will teach you how to calculate the probability normally in the standard normal distribution. The standard normal distribution, always, once we have these different normal distribution and change it into standard, the mean will become 0. And the standard deviation, sigma, will be 1. It means this is standard deviation, z. We'll say this is the standard normal variable, z or z. Okay? It follows normal distribution. What is the mean? It is 0. And what is the standard deviation? It is 1. Standard deviation is 1, square it till variance will be 1 as well. Because as we said here, the variance, not the standard deviation. So square it, also 1. So this is when we see that one, it means z is a standard normal variable, follows standard normal variable with mean 0 and variance 1. It means standard deviation 1. Okay? Next. طيب. الآن يا شباب, this is the curve of standard deviation. Look here. It is same. This is the standard normal distribution. How did we know? Look here. First of all, this is central. This is the mean. What's the value of the mean? It is 0. What are these values? What is this line? This line is not the x-axis. We will call z-axis. Z now. We are changing x into z. Inshallah, we will give you another video, another lecture, inshallah, how to standardize, the process of standardizing. But now, I'm not going to speak about the process of standardizing. I will speak about how to find the probability directly from the standard normal distribution. So this is the value of z, 0. The mean is 0. The value of z is 0. The value of z 1, 2, 3. Here, here -1, -2, -3, and -4. Okay? As we said, mu plus, look here, this is mu plus sigma. And this is mu minus sigma, because we say mu is 0 and the sigma is 1. So if you draw vertical line here and here, okay, what will be the area of that part? What is the area? It is 68%, as we say. This is property for all normal distributions. Okay? And the same thing here to here, the area is 95%. From here to here, mu plus 3 sigma, mu minus 3 sigma, it is 99.7%. Yani almost 100%. And so on. So this is the standard normal distribution. Okay. Don't forget that this is symmetrical. This is what? Symmetrical. Now, how to calculate really the probabilities in the events of normal distribution? طيب. Let's see that one. Please bring your book, because now I will ask you to go to a certain page really to discuss a certain point in order to discuss and explain for you a certain point. This is the standard normal distribution. Okay? Here, the total area under the curve is 1. Okay? Always, the probabilities in the normal distribution is calculated through the area. Calculated through the area. طيب, if I ask you now, this is the standard normal distribution curve. Okay? What will be the value of that area? This half. What will be the value of that area? It is 0.5. Because the total area is 1. So this is 0.5. And that one is also 0.5. From that line till the end here to the right, to extreme right. Tamam. Here the area in red is equal to probability of z more than 1. Look here, that one. What's the meaning of that? As we said, this is z-axis instead of x-axis. So it's very clear. What is this area? It is probability of z more than 1. All the values which are more than 1. Okay? Tamam. Here the area in blue. What about the area here in the blue? Look here, I have 0. This is 0. And this is -1. So what is this probability of what? We will say the probability that z between -1 and 0. Okay? This one, the blue one, the probability that the z, the standard normal distribution variable, standard normal variable z between -1 and 0, this is the blue area, represent that probability. Is it clear? تمام؟ تمام. طيب. If I told you now the area from here, z equals 1, and to the extreme left, what will be the probability? Yes, it will be probability of z less than 1. What about, suppose this one -2. What about if I told you what's the area? Z equals 1 to z equals -2. So you will say the probability of z -2 to 1. Right? Is it clear? So this is the situation. Probability of z -2 to 1. Okay? تمام. طيب. Okay, let's move to next point. Still, I'm giving you some important points which may help us to calculate probabilities in the questions itself. طيب, تمام. طبعا, once I said it is symmetrical around the mean, and this is the symmetry line, it means this area equals that area, right? And that area, the white one here, is equivalent to what? Equals to which area? This one, the white one here. Equals to which one? Yes, equal to that one, since it is symmetrical. It is like mirror, okay? The area of extreme left here equals the area of extreme right. The area of the blue here equals the area of the white here, and so on. تمام. Now, the last point before solving the questions, I have to speak about the timetables. كم وقت باقي لنا؟
22 دقيقة.
تمام. Inshallah, within 5-6 minutes, I will speak about the timetables. Then in the next video, inshallah, we will solve questions. بإذن الله تعالى. Please, all of you, open your book page. Page 222. All of you, please open your book, page 222. Okay? I'm just giving you, please, some important points before solving, please, the questions. Okay? طيب. This table, really, the standard normal distribution here, table. Look here, this is the variable z. This is z here. Values of z. Here I have to the left, extreme left, we have a column here, and here we have the rows. All of these, the upper row here and the left side column deals always with z. Okay? While the values here at the body, main body, okay, of that table is are the values of the probabilities. Okay? So here, this is z here, and this is the row here, and this is here the column. I will tell you how to deal with that table in order to solve questions. So I have two figures here. Look, 0.0, 0.1, 0.2, till 2.9. So I have two figures here, two digits here. Okay, always we have two digits here. The third digit is in that part. The fourth digit, it is in that part. What does it mean? يعني, if I have a value of z, okay, if I said find the probability if I want to deal with the value of z (1.345), خلينا أول شيء 1 by 1 by 1. Okay, if I want to deal with the value of z 1.34 and to find the probability, I'll speak with this table. As a matter of fact, always calculating the probability when the standard variable z less than, always, يعني this is the standard normal distribution. Okay, if I give you a certain value of z, طبعا as you know here, always in the z, this is 0. The mean is 0. If I told you 1.34, it means to the right of 0. Say 1.34. That table calculates always for me the probability when z less than this value. Okay? Less than, it means that part. If I want to calculate the probability of z less than 1.34, how to find it? Very simple. Very simple. Go to 1.3. Here, the first two digits. You have to go to 1.3. 1.3, what is 1.3? You have to go here. This is 1.3. Okay? Then next, here that one, let's say it is the hundredths place. Then this one, the thousandths place. Okay? So here always the whole number and the tenths always here, from that column. Then the hundredths place, you will get from that part. Finally, if you have thousandth place, now I will show you, you will get it from here. طيب, how to find the probability? Very simple. So this is 1.3, then go to 4. Go to 4. So this is the value. You have to read it. Read it, please. So 1.34, this is 1.34. What is it? It is 0.9099. This is the probability. This is what? The probability. Okay? What does it mean? It means from 1.34 to the extreme left covers 0.9099 from the whole area. طيب. What about if I have z less than? If I have z less than, let's say 0.875. Look at me here, please. Please look at me here. Always, in order to calculate the probability, z should be less than, not more than. Once we solve questions together in the coming video, inshallah, I will inform you how to deal with the more than. طيب, 0.875. How to find the probability? So since I have z less than, directly I can go to the tables and find out the value of the probability. طيب, how to find 0.8? Where is 0.8? Yes, this is 0.8. Okay, then 7. This is 7. 0.8. This is 7 here. Then I have, look here, 5. We say 0.875. What does it mean here? You have to go here, and what you have to do? Just you have to add. It's written here, add. You have to add 14 to the last two digits. You have to add 14 to the last two digits here. It means 0.8078, then add that value, 14, to the last two digits here. So what will be the probability? 0.80. So here 29, if you add it. So this is the probability, 0.8092. So always if you have thousands place, okay, you have to add to the last two digits. Inshallah, in the coming video, we will continue to solve questions. Thanks a lot for you. Assalamu alaikum.